All right, this video is going to go over the circle slash ellipse. There's going to be a lot to it. Should be everything you need to know about an ellipse. So let's go ahead and get started. The first thing that I would say is that you're going to know it's a circle slash ellipse because it's going to have x squared over a number, and then in the middle is going to be a plus, and then y squared over a number, and then it's going to equal 1. So these are your giveaways that you're dealing with a circle or an ellipse. If it was not a plus in the middle, if it was like a minus, then you'd be dealing with a hyperbola, which is different. So make sure you identify it as a plus, and then you know you're dealing with either a circle or an ellipse. The next thing is these numbers on the bottom. If they're the same, you're dealing with a circle. If they are not the same, you're dealing with an ellipse. So that's something really important to know. Another thing that you need to know is that you get the center of the circle or the ellipse by looking at these numbers. It's almost like your HK, but they're both lying. So like this one, the center would be at 4, -3. So like here, okay? So you need to change both of those numbers. So like this one, the ellipse center, this one, the ellipse center is at 3, 1. Okay. Let's see, what else is there? Just looking at something like this, if you don't see it over a number, it would be over 1. And then what these numbers represent on bottom, you need to square root these numbers, and that's your distance from center. So here's what I mean. Looking at number 8, for example, my center is at 0, 0 because there's no shifts on near the x squared or the y squared. And then this is an ellipse because these numbers are different. So on the x, the square root of 81 is 9. That means I go 9 to the right, 9 to the left. So the number under the x rooted tells you how many left and right to go. And the number under the y, the square root of that is 12. That's how far up and down you go. So it'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the same thing for up high. And that's how you actually draw these ellipses. So that's a little bit of background. Now let's go ahead and look at some examples. The first one I'm going to look at is number 10. Just looking at this, I know it's a circle because they're both over 9. I know my center is at 0, 0 because there's no shifts next to the x squared or the y squared. So I have a center here. The amount I move in the x direction, so left, right, is the square root of that, so 3. So I move 1, 2, 3 to the right, 1, 2, 3 to the left. And the amount up and down that I move is the square root of the number under the y, so 3. So 3 up, 3 down. Then you can draw your circle. Okay, that was a terrible circle. Let me try that again. That's a little bit better. And so like that is basically all you're looking for there. You know it's a circle. You know the radius of this circle is 3, and there's nothing to it. So that's like best case scenario when there's no shifts or anything. Let's look at another one. The next one I'm going to look at is number 18. So this one right here. Just looking at it, I know it's going to be a circle because they're both over 25/4. That means it's a circle. So I would go get the center of the circle, which would be at +3, +1. I mean, yeah, so 1, 2, 3, 1. There's the center. Okay, and then the amount that you move left or right is the square root of this number. The square root of 25/4 is 5/2, which is 2.5. So I'm moving 1, 2.5 to the left, 2.5 or sorry, to the right, and then to the left as well. And then for the up down, same thing. The square root of this is 5 halves, 2.5. So I'm going 1, 2.5 up, and then 1, 2.5 down, and then I have my circle. So even though it's a fraction, don't let it confuse you. Just stick to the plan and square root it, and that's how far left, right, or up, down that you have to go. Not that big of a deal that it was a fraction. Okay, the next one I'm going to look at is number 7. Okay, this one, just looking at it, I know it's an ellipse because my x is under or over 25 and my y is over 16. So those numbers are different. That tells me it's an ellipse. So if I was approaching this problem, I would go get my start, my center, which is 0, 0. And then in terms of this ellipse, for the x, so left, right, I'm going the root of 25, which is 5. So that's 5 to the right, 5 to the left. Okay. And then for the y, it's the square root of 16. So that's 4. So 4 up and down. So this ellipse would look something like this. Okay. So once you're there, there's a couple things you kind of need to go and find. So what's happening here is every ellipse, whether it's vertical or horizontal, has a center. And then it has 2 dots here that are called foci. And often you're going to need to know this distance from center to foci. It's kind of an important thing to go and find. So the way you do this is you have to imagine a triangle with your minor axis to center, to foci, and then back. All right, so imagine this triangle, right? Now, this minor axis, this distance right here, it's the same as this distance right here. So that's 4. We don't know this distance to foci. That's a problem. But what's going to help us is this right here, the hypotenuse of this triangle, is going to be half of your major axis. So in this case, that's 5. And so what you can do is you can do Pythagorean Theorem to solve for this. And if you do that, you will get 3. This distance is 3. So generally, if you go and approach a problem and you look at these numbers and you root them and you're like, okay, A is 5 and B is 4, you can always just run a quick A squared minus B squared equals C squared to solve for it. And I know that looks kind of weird because you're used to Pythagorean Theorem where it's like A squared plus B squared equals, C squared. The reason it looks weird is because you're calling this A and this C in these scenarios, okay? Like look back at this, you'll be like, oh yeah, that was my A, this was my B, and we were solving for C here. So you can use A squared minus B squared equals C squared right from the start to go and find that distance to foci, is what I'm trying to get at. Because what's going to happen is they're going to want the coordinates of the foci. So if my foci are like here and here, you write them as coordinates. And the way you do it is you start at your center, which was 0, 0. This is center. And to get to the foci, you basically just, so this one would be affecting my x values since it's left, right. So it'd be like 0 plus minus 3 comma 0, because that would give me 3 comma 0 and negative 3 comma 0. I hope that made sense. That's kind of an important piece of information to have. All right, so you knew what A was, you knew what B was, you solved for C. And then the other thing that they might ask you about an ellipse is the eccentricity. Basically what eccentricity is, it's how circular this ellipse is. It's like a rating of how circular it is. And so all you have to do this is go C over A. And you're referring to these A's and B's and C's that you've been solving for the whole time. So remember, like the bigger number rooted is going to be A. So like look at number 8, for example. A is 12. B is 9. All right. And so you would use this to find your C, for example, and then you're just running C over A on those to get eccentricity. So back to this example here, C over A would be 3/5. That would be my answer for eccentricity. I hope all of that made sense. Let's look at a harder problem. Number 8. The only reason, okay, number 8's not much harder. The only reason it's different is because looking at number 8, the bigger number's under your y. So that means this is going to be a vertical ellipse. So like I would still go find my start, which is 0, 0, because there's no shifts. It would be A is 12. B is 9. So that means I go 12 vertical and 9 horizontal. So this is like a vertical ellipse. So yeah, now I would be looking for my C value to get these foci points. So I would be like, all right, A squared minus B squared equals C squared. So this is going to be 63. So when you root 63, you get 3 root 7. So in terms of labeling where my foci are, it's on the y now. It's vertical. So it'd be like 0 plus minus 3 root 7 for those foci. Notice it affected the y value this time, not the x. All right, and then the eccentricity of this would be C over A, which is 3 root 7 over 12, which you could reduce to be root 7 over 4. That would be my answer for eccentricity. All right, moving right along. Let's get to some of the ones where it's not just at 0, 0 the entire time. Okay, we're having technical difficulties. And we're back. All right, the next one I'm going to look at is number 13. So looking at this problem, I know it's an ellipse because 16 and 25 are different numbers. I know that my center is not 0, 0 because there's shifts on the x's and the y's. So I would go get the center of this, which would be at 3, 5. Sorry, negative 3 comma 5, negative 3 comma positive 5. All right, I would go get A and B. So A is going to be 5 and B is going to be 4. So that means vertically I'm going to go up 5, down 5. We're going to kind of run out of room. That's okay. And then left and right 4. Okay. This is a vertical ellipse. Looks something like that. Now you're going to need to go find the foci. So they're going to be somewhere like here-ish. And so you can run your a squared minus b squared. So that's looks like this. All right. And so in terms of answering where those foci actually are, what you do is you take your center, which was at -3, comma, +5, and you're affecting your y value here. So you attach that ±3 to the y value, that 5. And then the only other thing to answer about this is eccentricity, which is c over a, which would be 3/5. That's all there is to that one. Okay, moving right along. Now we get to the ones where it's not already in standard form. These, if you have not already done so, I made a video for how to convert it. You're going to have to do like a double complete the square. If you don't know how to do that, you need to go watch that video right now. Otherwise, you're going to be very, very confused as I go through these. But let's look at like number 21. So I'm not going to show all of that much work or all of that many steps. I'm going to kind of assume that you've watched that video. So here we go. I'm going to go ahead and group them. I'm going to go ahead and double complete the square. I'm going to combine like terms and move stuff to the other side. Now I'm going to divide by 36. This over here is going to become equal to 1. And so this is now in standard form. And so now I realize that, oh, okay, I'm dealing with a circle because they're both over 36. The center of the circle is not at 0, 0. The center of the circle is at +1, -2. So 1, -2. The radius of the circle is the square root of this, which is 6. So that means 6 every direction. Okay, it's not going to be a very good circle, but that's okay. All right. And so now I'd just basically be done. I would just say the radius is 6. Nothing to it. But if you don't know how to double complete that square, you're really going to struggle with that. Okay, let's move on. The next one I'm going to do is number 19. All right, same thing. So I'm going to go ahead and group it and all right, I'm going to GCF both of them and complete the square. I'm going to redistribute. I'm going to combine my like terms and move them to the other side. I'm going to divide by 36 and reduce to have my final equation in standard form. And I got that because I was dividing this by 36, all of these. All right. So now that I'm here, I realize that I'm dealing with an ellipse because one of these is over 4 and one of them is over 9. So I have an ellipse. My center of the ellipse is at -4, +3. All right. A is 3. B is 2. So that means it's the A is under my Y, which means vertical 3. 1, 2, 3 up. 1, 2, 3 down. Then horizontally, I go 2. So 2 to the right, 2 to the left. This ellipse would look something like that. Now they're probably going to want to know foci. All right, so you do your a squared minus b squared equals c squared, and you'll get 9 minus 4, which is 5. So c is plus minus root 5. So that puts it like, I don't know, somewhere like here or something. And so to answer where the foci are, it's a vertical. So write down your center, which was at -4, 3. And you're adding that plus minus root 5 to the y value because it's vertical ellipse here. Okay. And then the last thing that you're probably going to need to know here is the eccentricity, which is just c over a, which is just root 5 over 3. That's how you do that problem. That's a realistic problem. Okay, now let's get to a hard one. 24. Okay, I'm going to first group things. I'll try to show more work on this one because this is a difficult problem. Okay, now that I'm here, I'm going to GCF both of these things. The reason this one's going to be kind of trickier is because when you complete both of these squares, you're going to have some fractions. It's okay. So this is what it would look like. This first one would be x plus 3/2 squared. And then the L of that FOIL would make 9/4, so minus 9/4. Okay, this next one, it would be y minus 5/2 squared. The L of that FOIL would make 25 over 4. Okay. Now you still have to go and redistribute. So what that's going to look like is this. I'm just going to leave it 54 over 4 for now. This is the second part where I redistribute that 6. The second one would look like this. And then I'm just going to leave it 50 over 4. All right, now that I'm here and I've redistributed, now I'm going to combine these two fractions. So here's what it's going to look like. All right. and it equals 0, sorry. And if you think about this right here, that's just 26. 104 divided by 4 is 26. So I'm just going to change this to be minus 26. All right, and now I can combine these other like terms and proceed and everything. So here's how I'd finish this problem. Negative 26 plus 2 is negative 24, and then I'm going to send it to the other side, so it's going to become plus 24. Then I'm going to have to divide by that 24. So my final standard form of this equation would be x plus 3 halves squared over 4 plus y minus 5 halves squared over 12 equals 1. This would be standard form. That was a challenging one because there were some fractions, but it's not that bad. All right, so now I know a is the square root of 12, which is 2 root 3. B is the square root of 4, which is 2. And so I have an ellipse. The center of this ellipse is at negative 3 halves, positive 5 halves, which is like negative 1.5 comma 2.5 if you don't like fractions. So negative 1.5, positive 2.5 would be like here. All right. The bigger number's under the y, so it's a vertical ellipse. And so I'm going up 2 root 3. You can just kind of estimate. That's going to be like, I don't know, 3, a little bit over 3. So I'll just call it 3. Here. It'd be like here. And then left, right, 2. So it's going to be somewhere like here. And like here. It's not perfect. That's okay. And then all you need to do is go find the foci, which are going to be somewhere like here. And you still just run your a squared minus b squared equals c squared. And so you get 12 minus 4, which is 8. So you get c squared equals 8. So c equals 2 root 2. The root of 8 is 2 root 2. So in terms of labeling where these foci are, take your center. It's a vertical ellipse, so I'm going to be adding that 2 root 2 to the 5 halves. That is where my foci would be located. Okay. All right, sorry about that. I was looking at my answer key. My answer key did not agree with me, but I messed up on my answer key because I called C here. I accidentally ran a squared plus b squared on my key. So don't make that mistake, okay? But anyways, I'm standing with my plus minus 2 root 2. All right, and then the last thing is the eccentricity, which is just C over A, which is going to be 2 root 2 over 2 root 3, which the 2's can cancel there, and you can just call it root 2 over root 3. And if you're rationalizing your denominator, your answer would be root 6 over, sorry, I got confused there, root 6 over 3, if you rationalize your denominator. All right, that was a very, very difficult problem. That's like a test question right there. So the reason is because we had a bunch of fractions and roots and all sorts of other things. Let's keep moving. I only have a couple more that I want to go over. The next one is if they give you just some of the information, like these down here, and they ask you to draw it and do all the stuff for it. Okay, we're having technical difficulties too. This is not the best video that I've ever recorded. All right, the next one I'm going to do is number 37. They give me vertices and the foci. Look, even me, I can't do these until I throw them down on a graph and see them visually. So that's where I would recommend you start. Now, if they give you, oh geez, here come those technical difficulties again. If they give you the foci, they tell you, essentially they're telling you if it's a vertical or horizontal ellipse. So by them giving me these foci at plus minus 2 comma 0, they just told me that it was a horizontal ellipse. And also, same thing if they give you, well, I can't really tell you the same thing for vertices, but you're going to tell if it's vertical or horizontal based on your foci. But they also gave you 2 vertices. So plus minus 6, 0. All right. And they're going to want like probably like the whole equation for this. So here's how you do this. Essentially, you're going to go and find, remember this triangle? You know this is 2. And this distance, remember, your main half of your main axis is your hypotenuse of this triangle. And so to find this distance, you can just run Pythagorean Theorem. You'll get root 32. Root 32 is 4 root 2. So now I know that it's up 4 root 2, down 4 root 2. All right, and so now you could write the equation for this by just kind of thinking of it as, okay, well, there's no shift on the x, so it's just x squared. It's horizontal, so my a goes under the x, and the major length, half the major axis length was 6. This right here was 6, so square that and you get 36. All right, now there was no shift vertically on the y either. And you want the square version of that vertical minor axis, half of its length. So that would be 32. And then you just say it equals 1, and then you'd be done. I hope that wasn't too confusing. You have to go get this half the minor axis length. That's what I'm trying to get at. Okay, one more. Let's look at number 39. This time they just give me a foci and they gave me a major axis length of 12. Well, again, I cannot do this without throwing it onto a graph. So foci plus minus 5 comma 0. That means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They just gave me my center as 0, 0. So like if I was writing an equation, if that was my overall goal, oops, not b squared, y squared. You could go ahead and put that down. Now they tell me the major axis length of 12. Well, major axis on this one, it's going to be a horizontal ellipse because those foci are horizontal. So it having a total length of 12 means it's 6 and 6. Okay, that's how you kind of need to be picturing it. So 6 and 6, this ellipse would look something like this. And so you've got to go get this distance again by making this triangle. you know this distance is 5, and this distance is 6. And so you can just run Pythagorean theorem to get this question mark here. So you get like 36 equals 25 plus question mark squared. I'm just running Pythagorean theorem. I got root 11. But you really only care about this number because it's going to be squared in your equation anyways. But all right, it's horizontal. So that 36, that major axis, half of its length squared goes here. The 11 goes here, and I would be done. Sorry for not my best video ever. Hopefully it still kind of helped you. There's a lot to a circle and an ellipse. Drawing it helps. That's what I'll try to tell you. Drawing it helps, and if you can't do the double complete the square, then there's no point. So I hope this video helped.